And share my screen. Here we go. Okay. Thanksgiving week. Woohoo! So after today we have 5 classes. No, including today we have 5 classes left. Only 2 more weeks after Thanksgiving. So you're working on your Reddit project right now. And there'll be only one last major project in this class. That will be, right now you're writing sort of code that interfaces with somebody else's social media website, the bot run on your computer, and it's talking to somebody else's website. Your next project, what we're talking about next, is like the opposite half of that you'll be building the website that somebody else will be interacting with. And that somebody else, it could be a bot or it could be a human being. You don't care, you're just going to build the website. And starting today, we're going to talk about the tools for doing that. We've talked about everything that you need, again, for the Reddit assignment at this point. So we're going to be switching gears today. And there's going to be, just a quick overview of like what is left in the course. There's 2 more quizzes, 1 quiz each week of after Thanksgiving, and there's no final exam in this course. Instead, you'll just have this last programming project, and over Zoom during finals week, you'll have to demo your programming project to me and explain how things work, and talk about the details of that later. But those are the only 3 things left in this class: 2 quizzes, 1 big project, and I guess the Reddit project if you're not totally finished with that yet, which is okay. Any questions about anything administrative wise? What to expect remainder of the course?
You said that the demo is going to be through Zoom.
Demo will be on Zoom, so whether you are here on campus or up on the moon, I don't care, wherever you want to be to do that, as long as you have internet and can connect over Zoom. And it'll typically takes about 5 minutes for a student to demo it. So don't expect it to take a lot of time. Any other questions, anything administrative wise or anything about Reddit? There were a lot of great GitHub issues about Reddit over the weekend. I went through last night and responded to all of them. All of them are good ones that are applicable to everybody in the class. So if you haven't paid attention to those, haven't read those, I recommend that you do. And speaking of issues, I've just posted this one here this morning. Before next Monday's class, you're going to want to click this link right here and download this program called SQLite that we're going to be using this program starting next week, and so it'll help you to have that on your computer. Okay, in class today we're going to talk about this SQL programming language and your quiz for next week. But before we do that, last chance for questions about anything at all. Okay. Yes.
So when you connect to Reddit, you like use prog, you connect it, and then is this subreddit the title like the CS40_2022 fall?
That is the name of the subreddit. Yes.
Okay.
Yep. Yes.
As long as you're posting comments to any of the posts within CS40, 2022 fall, that's okay. Right? Like the practice posting or the comments, because it still counts them as valid comments.
Yeah. So the question is like, what are the restrictions on where you post the comments? And the answer is just as long as it's any of those submissions, doesn't matter at all. And they'll all count towards that valid comments and count towards those points in your grade. Today in class, I have to scroll down so far to get to our folder here. We've covered so much stuff. We're going over this topic 11 folder here at the very bottom. And there's 2 handouts for today. These 2 files right here that end in .sql. And again, these files are the basis for your quiz, which we'll be having next Wednesday, and we'll be going over these files today. It's okay if you don't have any SQL programs installed on your computer because we're not actually going to be using VS Code today at all. Instead, we are going to be using this website, SQL Fiddle, and SQLfiddle.com. Again, in this task over here that I just posted, if you want just a clickable link, it's this link right here. The SQL is an example of a programming language. It's usually pronounced SQL. So this SQLfiddle.com, that's the website that we're going to go to. And the two handouts are these two handouts right here. So another new programming language. We've seen a couple of different types of programming languages so far, and they fall into two main categories. The first category is a markup language, and we have three examples of that: HTML, CSS, Markdown. And the idea of these languages is that they tell the computer what to display, and the computer will figure out how to display it for us. So because we're focusing on the what and not the how, these languages are much, much simpler than Python, which is sometimes called a procedural language, where you actually tell the computer step by step how to accomplish a particular task. And because these languages up here are simpler, anytime it's possible to use them, we want to use them because it's just much, much easier than doing everything in Python. SQL is an example of what we call a declarative programming language. It sits somewhere between these two other languages in terms of its power. And SQL is similar to the markup languages in that you're telling the computer like a what thing, but here we're telling the computer what to compute instead of what to display. And the computer is automatically going to figure out how to compute this for us. If that doesn't sound cool, some motivations for why you need to know this. So two reasons right here. First reason, every web page on the internet, so literally every single web page that you've ever visited has a SQL database inside of it. So a data set that's manipulated using this SQL language. And data scientists are the people who are taking that SQL database and running SQL code on it to extract and process interesting information. We talked way back at the beginning of the course about data scientists getting paid lots of money, computer scientists getting paid lots of money. And if you want to get one of those nice high-paying jobs, you'll have to go through a technical interview process. And the vast majority of those technical interviews for data scientists are going to involve SQL problems, where people will just give you a SQL database and say, compute this thing for me, and you'll have to, on the fly, program in the SQL code to do that. Very, very practical stuff that we're covering here. We're not going to be covering anything remotely advanced about SQL. So CS36, the Foundations of Data course that probably some of you are signed up for next. We'll talk a little bit more about SQL, but then this CS133, the Big Data course, is really the one that it's like a whole semester on SQL and really going into the details here. Our focus is basically going to be like the why should I care? So we're going to do just enough SQL that we can understand what's going on, and then we're going to focus on connecting SQL to Python. In terms of references for this part of the course, and for your quiz material, it's these 5 links right here. There's 5 SQL commands that we'll be looking at, and you're responsible for all the material in these 5 links. And then starting next week, and not on the quiz, but part of the homework assignment, we'll start talking about connecting SQL with Python. So what we're going to go over to next is the SQL Fiddle website. Before I do that, though, any questions at a high level about SQL? Okay, so there's 2 files, again, for our quiz that you'll need. This quiz practice problems.sql and the practice quiz schema.sql. When you visit sqlfiddle.com over here, you have 2 like little panes, little text editor things where you can type things in. And this left box over here is where you should put the schema file. So you can just take the, is this the one, where did I open my schema? There's the schema. And I'll just press the raw button here and Control A, copy all that whole thing, and we'll come over to SQL Fiddle over here, Control V, paste that right here, and then you press this blue build schema button down here. You notice that when you do that this very first time, come on, computer. Okay, let's reload this web page. Come here, paste that here, build the schema. And the very first time you do this, you should get this error message down here or some sort of error message. And the problem here is there are many what we call dialects of the SQL language. Sort of many different versions of the SQL language. They're all like 99% the same as each other, but just some subtle differences. And the default one up here that they have selected is this MySQL database, this MySQL language. We're going to come down here to this SQLite language, and it shouldn't matter which one of these two you pick, but I'm going to do the bottom one here, the SQL.js, SQLite SQL.js, like that. Now, when I do that, I press this blue button down here, building the schema, and it says the schema is ready. And now over here, I can type things into this window over here.
Where did you get that code on the left?
So the question is, where did all this code on the left come from? And the answer is that over here in the practice quiz schema.sql file, I just press the raw button. So I get access to all the contents of the file and copied and pasted this into this window over here. And again, this, all of this is one of the printouts, one of the handouts for today, one of the things that you'll have access to on your quiz on Wednesday. Good question. Any other questions so far about the setup? Okay. So again, this thing on the left is called the schema of our database, the schema of our SQL program, and it contains all the information about our that we're storing for our web page. The web page that we're creating is going to be a Twitter clone. And so it's going to have users inside of it, and it's going to have messages, and users are going to send messages to each other. And so that's the information that we have to store in this database. We're going to go through exactly how all this is working, doing that today. But over here on the right-hand side, I'm going to give us our first basic SQL command with the select statement, and it'll be select star from users, like that. Let me zoom in here a little bit, make this a little bit easier to read, possibly. And so it's a select star. This star right here is just the asterisk, the multiplication from Python. And then if you press this run SQL button down here, then it will give you this little table of all of the information. And the semantics, the meaning of this table is that these are all of the users that are going to be in our web page. So this is all the user accounts in our web page. This users right here, this must match one of these on the left-hand side in this schema area, one of these create table commands. Here it says create table users. So this users corresponds to this users right here. And then when you run this command, what this information is, this is all the information inside of this table. And you can see there are 4 columns in this table: the ID, the username, the password, and the age. And those 4 columns correspond to these 4 rows over here in this users table. I know there's going to be 4 columns down here in my output because these are the 4 column names over here in the users table: ID, username, password, and age, corresponding to these columns up here. There's a lot of extra information over here, which we'll get to in a little bit, but for now you can just ignore it. And the important thing is that these things right here are the sort of titles of the columns over here. Any questions at this point? Everybody's able to run this and get the same sort of output? Okay. Our schema over here has two tables inside of it. It has this users table and it has a messages table. So if we scroll down a little ways, here's this create table messages right here. And we can see that there's also 4 different things listed inside over here: ID, sender ID, message, created at. And so if I were to change this from users to messages, then we will get all the messages that have been sent from one user to another. And again, 4 columns up here corresponding to these 4 rows over here. If I were to type in something else over here, like just singular message like that, then there is no table that corresponds to that messages. And so we get this error message down here. One of the frustrating things about this SQLfiddle.com webpage is that these error messages are like impossibly bad. I couldn't imagine having a worse error message down here. All it says is that something bad happened. And this is basically going to be the error message you get no matter what you have over here. For the purposes of our quiz, the quiz problems, again, are in the other handout over here. Each one of these commands corresponds to one quiz problem. All of these quiz problems have no error messages in them. There should be no typos. And so if you do get an error message, then it means somehow you probably copied and pasted the problem wrong into this area over here. But this is the area where the problems go. Okay. So let's start talking about the first problem, what we need to know in order to do the first problem over here. So again, select star from user. This is going to give us all of the information. Oops, again, it's not from user, it's from users, plural. Run SQL, there we go. Gives us all the information that is stored in this users table. These insert statements down here, we'll get into exactly what they're doing in a little bit. But these are the statements that are putting the information inside of this table up here. And these statements over here are the statements that are somehow selecting the information, getting the information out of the SQL table on the left. We said that this from users means that this thing over here is a table. This star over here, let's talk about what this means next. Everything between select and from is your list of columns that you want in your output down here. The star means get all the comments. In general, anytime in any programming language, a star appears, a star somehow means like get everything. And so there's four columns, so star gets us those 4 columns. If I only wanted to get like the usernames, then I could say select username from users, run SQL like this, and now my table down here gives me just the usernames and not the and not any of the other columns. Here, yeah, so it's returning, giving us a bunch of different usernames. Let's now take a look at what this actual first problem is over here. Problem 1, so it has select ID from users. So we've talked about this whole part of the statement. The ID is going to be the column that it's getting. The users is the table that it's looking at. The last thing that we have to look at is this where clause over here, where username equals Trump. So I'm going to paste that command over here on the right-hand side. Again, each of those problems is going to be pasted on the right-hand side over here. The left-hand side is going to be the same for every one of the problems. And what this where is going to do is it's going to filter through the whole table and only give me the ID if the username is Trump and not give me all the other IDs. So if I run this SQL command like this, we get ID equals 1 right here. And that's the, for the purposes of the quiz, you would just write the number 1 and you would get full credits. We're going to go in now and just see exactly why, again, we're getting the number 1. And in order to do that, I'm going to change this. Let's see. So in SQL, you can comment something out with this double dash right here. In Python, for a comment, Python uses this for a comment. In SQL, you use 2 dashes next to each other for a comment. And so in order to figure out why exactly this, this command right here gave us the number 1, we're going to redo our select star from users command. So getting everything from the users table right here, run that SQL command. Come on, web page. Come on, web page. I'll come up here and just refresh this web page. After refreshing it, I'll have to rebuild this schema, then come back over here and run SQL again. And there we go. And so our, again, the select star from users gives me all of the contents of this table. This one up here, the answer for this, what it gave us was just the number 1. What it did was it finds all the rows where the username equals Trump. So here we have all of our usernames in this column right here. Only one of those rows has username equal to Trump. These other ones do not have username equal to Trump. And then the column that we're looking for is the ID column. And so we get the number 1 right here like that. Again, so what the where clause does, the where clause filters the rows so that it only gets the rows that match this condition right here. And then the thing between the select and the from tells us which columns it's trying to output.
How do we get the ID variable? Because it looks like we insert username, password, and age, but it says for ID it's just integer primary key. What's that mean?
Yeah, so the question is, where exactly did this number 1 come from? And it's a great question. The let's pause that question and in order to okay, let's go into that question in detail. So in order to, so the question is, this ID right here corresponds to this 1. Why exactly, when we do select star from users, why exactly is this entry a 1 right here? And that, in order to answer that, we have to talk about how did the information actually get into the table. And so on the left-hand side over here in the schema, we created the table right here, create table users. And now down here, we're going to insert the information into users, insert into users. And the format of this insert command, we have, so insert into, then the table name that you're inserting into, and then a list of columns that you're going to insert information into. So we have a username, a password, and an age column. And then the values, Trump 76, that we're actually inserting into this table in these 3 columns right here. These 3 columns, the usernames, whoops. These names right here, the column names right here have to match the column names up here of the table that you're actually inserting into. And here, when it says not null, that means you actually have to specify one of these values. So the username text not null, we have to specify a username value. We have to specify a password value. That if you're running a website and you're having user accounts, every account needs a username and a password. An age is something that maybe you want to specify, maybe you don't want to specify. And so here, most of these accounts have an age specified. Here's how old Trump and Biden are. These are all my kids and their ages, 4, 1, and 0. This is me. And then, but my wife, she didn't want me to have her age blasted out to the internet. And so we didn't specify an age for her. And so there is no age there, and that's okay. But the username and passwords, they have to be specified. You'll notice that we're not specifying this ID up here. For every table, it's common to have the very first column in that table be an ID, and it has this integer primary key as so we sometimes call these the attributes of this ID over here. The integer means that every ID is going to be a number. And then what primary key means is that it's never something that you actually manually add over here. You'll never add ID in this list of columns. Instead, the ID is going to be created for you automatically, starting at 1, and then every time you increment this, every time you insert something else, it'll automatically go up to the next ID. So you can think of the ID as sort of like a row number. Think of ID as like the row number. And there are complex technical reasons about why every table almost always has an ID in it. At this point, we don't care about that. That's something, if you go on to take big data, we'll talk about extensively. But at this point, you just need to know that it has this ID in it. Similarly, the messages row down here has this ID in it. And we're not specifying it manually, but it's automatically getting created for us. The bigger purpose of the question was up here when we run, we'll do it again, this command. We run this command, and it's going slow again. There we go. How did we get these ID numbers over here? How could we know, for example, on a quiz that these are going to be the appropriate ID numbers? Well, it's the Trump user account was inserted first. The Trump user account was inserted first, so its ID will be 1. If we were looking for Isaac right here, that account was inserted 4th, so its ID will be 4. Python, like most programming languages, starts counting at 0, but for whatever reason, SQL starts counting at 1 instead of 0. So the very first row is going to be row ID 1 and not row ID 0. Did that answer your question? Great question. Any other questions so far?
To get a SQL file hypothetically in VS Code, would you just do .sql?
Yes. So the question is, in VS Code, like how do you create these files? And you just end the file name .sql. This is just a text file, so there's nothing special about it. It's just that the file extension there that lets us know it's a SQL file and not a Python file or something else. Good question. Any other questions? Okay. So the ID bit here is a little bit confusing, but I think not too bad that it's, once you just think of it as a row number. Let's get a little bit more confusing. So if I run this command again, we get the number 1 out. If I change this capital T to a lowercase t like this and run this command, you'll see that we get no records as output. Here, the SQL Fiddle website uses record count to indicate the number of rows that were returned. So there are no rows returned. And if on your quiz, like in problem number 2 right here, I ask you a question where you're not going to get any rows returned, then the thing that you just should be indicating no output like that, right? No output. And that's how you indicate that no rows are returned. The reason that no rows are returned right here is because SQL is case sensitive inside of strings. And so this username lowercase Trump doesn't exactly match the username uppercase Trump. And so it doesn't return anything. But SQL is not case sensitive. The confusing part here, SQL is not case sensitive outside of strings. So Python is case sensitive everywhere. SQL is only case sensitive inside of strings and not case sensitive outside of strings. So for example, this select right here, I could type in something like ridiculous like that and make this all lowercase, this one all uppercase, and we run that. And we get the same results down here, no error. Change this back to a capital Trump so that it runs. There we go. And so it doesn't matter what sort of lowercase and uppercase I give you. It's always going to be, it just doesn't matter. Even for these like table names and things like that, run that, and we still get this down here. Username like that. Still get this one down here. So the only place that SQL is case sensitive is inside of strings. It's customary to make all of your column names and table names lowercase and all of your like actual SQL commands right here, these things in purple, to make them uppercase. It's customary to do that just for readability purposes, but people don't always do that. It's also very common that people will just out of laziness make everything lowercase. And you can see that I kind of, on the left-hand pane over here, the code that I gave you, I kind of go back and forth between being lazy, making everything lowercase, and then some commands having this nicer sort of formatting up here. Any questions about that case sensitivity? Okay, let's come back to a practice quiz. Okay, next problem down here. So we've seen equals conditions. I guess another difference between SQL and Python is that in Python, you'd use the double equals inside a condition. But there's a condition up here. We're not like assigning anything. We're not saying set username to be Trump. We're saying is username Trump? Select the things where username is Trump. And in Python, when you're asking a question like that, when you're doing a condition, you use the double equal sign, but SQL you use the single equal sign. SQL also has this new operator that's not available in Python called like. And like is like equals, but it's case insensitive. So username like Trump, like that, run that, still get the one down here, but now I can change this to be lowercase Trump like that, run it, and we still get the one over here. So this third problem, the key difference about this third problem compared to problem 2 is because we're using this like behaves like the equal sign, but it is case insensitive instead of case sensitive. Any questions on this like operator? Okay. This problem 4, I copied and pasted one too many times, it looks like. So that was exactly the same. Problem 5. This is null condition over here. So let's come back to SQL Fiddle, run our select star from users, take a look at this table again. And just remind ourselves that most of these values are not null. Most of these values have something inside of it. But this value right over here, so the Kristen username has age of null because the age was not specified. And again, the way that we know from the code over here that the age is null is on this insert command that corresponds to the Kristen username, there is no age specified. We're only specifying the username and the password right here. And so there is no age value. Anytime you do not have a column value specified, you get null. And null is basically like none in Python. And so in order to actually extract like the information from a row that contains a null value, what you have to do is, so let's do select, I think it was asking for the ID from users, where you can't do age equals null. If we do that, run that command, you see that we get no outputs down here. There is no output down here. Age equals null gives us no output. Age is null gives us the actual output down here. So this is a very confusing thing about SQL. Again, there's good reasons for it, but we don't have time to get into those good reasons for it. You just have to know that this is how SQL behaves, that if you're trying to select information on a null column, then you have to use the is null. And if you just do equals null, then it's not going to work. Very good chance that something related to this is going to appear on your actual quiz on Wednesday. So any questions about what that's doing and extracting it? Yes.
Yeah, so to get like the actual value of 7, we just have to count down until we find one that is.
Yeah, so the question is, how do we know that, so here the output is 7. How do we know that the output was 7? That these are the only inserts into the users table right here. So you have to figure out which one of these have the age being null. It's only this last one right here has the age being null because we are specifying the age in all these ones up here. And so you just count like 1, 2, 3, 4, 5, 6, 7. This is the 7th one that was inserted, and that's how I know it's a 7 down here for the ID. If I asked, say, for the username instead of the age, then it's easier. You don't have to count. You can just look that, oh, hey, there's no age specified here. Here's the username. And if it ever runs, that should hopefully be the output. A good question. Any other questions about null in SQL?
Wait, Mike, I actually had a question about the like that you just went over like 2 minutes ago.
Okay, the order of things that you get back in SQL is what we call undefined order by default, meaning that SQL gets to return whatever order is most convenient for it. It turns out that for small files, the order that's most convenient is the order that you inserted things in. But for reasons we'll talk about again in follow-on classes to this, that's not always the most convenient order. And so if you really need to specify the order, which you will definitely need to do on your project, that again, we're making a clone of the Twitter web page, and you'll have a web page that displays all of the tweets ordered by the most recent first. And so you'll do something like this in order to do that. This order by clause will order things for us. And let's go ahead and copy this over here and paste that there. So now we'll select the ID from users, order by the username. Anytime you're ordering by something, it's going to order it by the same way that it orders things in, oops, build the schema. Let's just refresh this web page. SQL fiddle is being fiddly for some reason. Schema, SQL. Okay, do I actually have an error message here? Select ID from users. Okay, it looks like I must have an actual error message there somehow. Order by username, SQL, descending, SQL. Okay, I think that's what I copied and pasted. So I don't know why it was giving an error message before, and now it is not. But there is the output of this that we have. Here are our usernames. If you were to order them ASCII-betically, this is going to do the sorting ASCII-betically, and then descending means going from the largest ASCII values to the smallest ASCII values. So Trump here, the T has the largest ASCII value. So this ID of 1 is going to be first. And then as an example, Aaron over here has the smallest ASCII value. And so this ID is going to be 5 because it's the 5th one down. And so the last ID should be 5. So the order by username descending, again, sorting by ASCII-betically. When you're, so on the quiz, I would give you something that looks like this. When you're like just working on it, trying to figure out why is it giving me these particular orders, a good way to figure that out is to add more information to this list of columns being returned over here. So instead of just returning the ID, we can also return the username like this, ID comma username. Run that SQL command for us. And now we can see here is the actual ordering of the usernames, and it does look like it's ordered ASCII-betically in reverse. Question?
The quiz, how do we write that down? It's like, are you writing about ascending? Where do you write it? Comma between?
Yeah, so the question is for the quiz, how would you write this down? And you'd want to write it like as a table, like 1, 6, 7, 4, 3, 2, 5, top to bottom going down. That way that it's clear that there are different rows and not say different columns.
Do you want us to label the columns of the table as the key?
Question is, do you need to label the columns of the table? And the answer is no. It's fine, you don't need to label it. Any other questions so far? Okay, so this first one is ordering by descending. If you want to go the other way, ASC is for ascending, and this problem 7 is going by age. So here, let's first do the username by ascending like this. Run that, and you'll see that the orders here get flipped around. And now let's change this order by to age over here. And just to help me with my debugging purposes, again, I'll add the age column like this, ID comma age, and run that. And now here you can see that the null value is at the top, and then the 0, 1, 4, and so on below that. If I change this ascending right here to descending, run that. And you can see that the null value is now at the bottom. So just the tricky thing about the null value is that it's being interpreted as the lowest possible value. There's not really like a good reason why null should be the lowest possible value instead of something else. They just need to pick a spot somehow to sort it, and so that's what they picked. Turns out there's more complicated SQL commands you can do to change lots of the various behaviors about the null. But that's the default. The main purpose here, or the main thing again to remember, is the difference between descending and ascending when you're ordering. Okay, problem 8. So we already did ordering by username ascending. Problem 9 is where we're starting to get into more interesting sort of things. That everything above has been just doing like gathering a single piece of information for us, just extracting information directly from the table without doing any sort of computations. Problem 9 down here, we're going to do some actual interesting computations. Here, let's go ahead and copy and paste this into SQL Fiddle again. And there's two things different about this command than the previous ones. The first one is that to the right over here, we have messages. So we're operating on a different table. And then to the left over here, there's this weird count star thing. I'm going to start off by changing this messages to users. So it's back to the table that we've been working on. And then this count star is the only thing that's new. Count star is what's called an aggregate function in SQL terminology. And again, that's not something that you'll be quizzed on directly, but I will use this word in class, and the references use this word. And anytime you have an aggregate function, you're going to have the output be exactly one row. Anytime you use an aggregate function, the output will be one row. So before using that, let's just remind ourselves. So take out the count, just select star from users, gives us many rows, this entire table. If we do select count star from users, what that's going to do is it's going to tell me the number of rows in the table. So the count star thing in particular is that it counts the number of actual rows. So there's 1, 2, 3, 4, 5, 6, 7 rows here. And so that's why count star from users gives us 7. The actual problem had count star from messages like that. So we haven't even looked at the messages table yet, but without even looking at it, I can tell that there are 10 different messages in the messages table. We'll take a look here at the messages table here in a minute before going on to more problems. But any questions about this count aggregate syntax? In general, in SQL, you can have very complicated things inside of these parentheses, and we're not going to cover what those do. But if you see this count, it's always going to be count star, and it's always going to be counting the number of rows. So let's come down here next to the messages table and think a little bit more in detail about it and what it does. So there's a bunch of messages, and it has the timestamp that those messages were created at, the contents of those messages, and then the sender ID over here. So the sender ID corresponds to an entry inside of the users table. That every entry inside of sender ID must match an ID inside of the users table. If we look at the definition or the schema of the messages table, so this command right here, this whole file, sometimes called the schema, and this individual command called the schema of this table. The schema of this table under the sender ID has this extra thing, references user ID, which we haven't talked about. But what that means is that every sender ID must exist somewhere in this user's ID table. And the semantics of that is that this is going to tell us who is the person who sent this message. It would be possible to, say, store the person's username instead of storing this user ID, but that's never done. One of the reasons that's never done is that if somebody wanted to change their username at some point, then if we were storing their username in a whole bunch of different places, we'd have to update a whole bunch of different places. But by doing things on this ID, this like invisible thing to the user, it makes things more efficient. And again, you don't have to understand why this is more efficient at this point in the class. You just have to know that sender ID means that it's going to correspond to one of the IDs in this users table. And the way you know who sent it is by looking at that ID. So here, the very first message right here, we have sender ID equals to 1. And so that is correspond to user ID 1. And this right here is Trump. So Trump sent a message saying, I'm a baby. And then so did Biden. And then so did my 2 babies down here. Any questions about that sender ID column? For the purposes of the quiz, it's not going to be too, I don't know, difficult using the sender ID, but on your actual projects, then you'll have to be like doing a lot of coordination between these two tables. And that's where the semantics of this will come into play. The other important or different column down here is this created at column. And so this is a timestamp. So a timestamp means like here's a date and a time. And this indicates the date and time that the message was sent at. On all of these messages down here, I actually like explicitly specified a timestamp. But up here, it has this default value that if you were to insert something without actually specifying the timestamp, it'll just do whatever the current time is. So for the purposes of the quiz, I manually added these things in case you need to be able to reference that information. But on your project, you won't when you're inserting things into the messages, you won't have to actually insert the time right here. It'll do that automatically for you because it has this default current timestamp. But again, for the purpose of the quiz, you can ignore this part right here. And then this also has its own ID column right here. This ID column is the ID of the message, and it's totally different than the ID of the users table. Here, these first ones, the ID and the sender ID happen to match each other, but eventually the ID of the messages is no longer correlated to the ID of the sender ID. And in general, there's no relationship between these two columns. It might seem like there is because on accident there is up here, but in general, there's no relationship. Okay. Any questions about the meaning of the messages table before we get back to the quiz problems? Okay, then here, so we have a count star from messages, adding this where clause right here. So save that, come over here, copy that, come over here, paste that right here. And now what we're doing here, again, this where clause is doing some sort of filtering, finding all of the rows that match this particular condition over here. And then over here on the left, we're counting those up, adding them all together. So we'll start, just for examples purposes, doing select star from messages where sender ID equals 4, taking away that count. And we can see there's exactly one message sent by a person who has sender ID equals 4. And so if we come back up here, we can see, so here's the fourth insert statement. So exactly one message written by Isaac. And if we change this to a count star like that, run that, then we can see it'll just give us the number, exactly one message here written by Isaac. If I want to count how many messages are written by, say, Evan instead of Isaac, then what I need to do is I need to figure out what is Evan's sender ID. Well, his sender ID or his user ID is 3. And so if I change sender ID here from 4 to 3, run that, then this is going to count how many messages were sent by Evan instead of by Isaac. And there are 2 messages sent by this account right here. The key thing here is that this where clause is going to do the filtering before the counting happens, that the count will always give you back one row no matter what. This where clause will filter out the rows, and then you'll be counting the total number of rows that match whatever the condition is over here. Any questions about that? Okay, so these conditions over here starting to get a little bit more complicated, having sender ID less than 4. So this could be something like we want to get all the messages by people created before some certain like event happens. So all the messages, count the number of messages created by sender IDs, like the first, in this case, the first 3 users of our web page, and there are 4 of those messages sent by the first 3 users. And then that's everything to know about the select statement. Any questions on any of the syntax? Yes.
Is it possible to do like less than or equal to?
Yeah, the question is it possible to do less than or equal to? And the answer is yes, just like that, it'll do it. And now it'll add the yeah, great question. Similarly, if you wanted to do like multiple conditions and sender ID greater than or equal to 2. Thank you. Sender ID, run that, then you can do that as well. Okay, the next part of the quiz. So typically students do really well on the select part, that it's there's no real hidden tricks. There's some things to learn, but once you learn them, it's pretty obvious what applies. There are some hidden tricks on the rest of this. And you can see now each of these problems has 2 commands inside of it. In SQL, you differentiate one command from another by this semicolon at the end of the command. And the first command is going to modify the table somehow. And the second command is then going to run a select statement. So this first question is about what this delete from syntax does. Paste this up here, run this command. And what we're going to see is that delete from messages is going to delete all the messages that have been sent. It's going to delete all the entries in this messages table. And so when we do select count star for messages, we get 1 row back, but that row counts 0 rows inside of the messages table. In our schema over here on the left-hand side, we added many, many different rows into this messages table. But then on the right-hand side over here, we deleted it and then we counted. And because we deleted it first, we get 0. Each one of these statements, these problems on the right-hand side is totally independent of each other. So even though I do the delete from messages and count star from messages here, run this SQL code, and I get 0 as the result. What? There we go, get 0 as the result. If I were to delete this deleting from messages line and only run the select count star from messages like this, what's going to happen is that it's going to reuse this same database on the left from scratch. It will not have deleted those messages, and so I will get all the messages back over here. So each problem on this quiz, you should think of it as 100% independent of all the other problems. That even though up here on problem 12, I did this delete from messages, as soon as we're at the beginning of problem 13 over here, it's like none of this happened, and the database is back to being just having the commands on the left having been run. So then again, delete from messages deletes everything in this table that you specify over here. That's something that you very, very rarely want to do. And you almost always will have this where clause over here, which somehow specifies only a subset of the messages to delete. So here, save that, come up here. Delete from messages where sender ID equals 1, then select count star from messages, run that. This up here is going to actually delete the messages where the sender ID equals 1. And then there were previously 10 messages. 1 message matched this condition right here. And so when I run the select count star from messages, I only get 9 things as a result. Most of the difficulty with this quiz is just going to be like keeping track of what exactly did this command up here do when I'm running this command down here to evaluate it. Yes.
For problem 12, do you want us to put 0 or no output?
Great question. So for problem number 12 looks like this. We run this command. And the question was, should we put 0 or should we put no output? And you should put 0 because it is actually outputting the number 0 right here. An example of no output would be if we just had select star like this and run this command. Now you can see that it says that the record count is 0 right here. And that's because there are actually no rows in here to be output. But when we add this count star, there is a row. It just happens to be a row that contains the number 0. Great question. And very important thing to distinguish for the quiz. Where am I going? So problem 14 and 15, all just the delete commands, again, with more interesting clauses over here. I'll let you experiment with those by yourself. Problem 16 is now using this update command. And we're going to take a look at update here. Copy both of these 2 things over here. This. And before we actually get into this there's a lot of new stuff here. Before we get into exactly what it's all doing, let's just take a look at this update command by itself. In order to see exactly what the update command by itself is doing, I'm going to run the update command. I know it's running on the users table because it's update users right here. This thing right after update is the users table. And so I'm going to select everything from users right here in order to see exactly what this command up here is doing. I'll run that command. And you can see what it's doing. So here it says set password equal to @RealDonaldTrump. So Trump's selecting very secure passwords for himself here. And this command up here, though, has no where clause attached to it. So it applies to the entire table. Anytime you have either an update or a delete statement without the where clause, it will apply it to the entire table. And down here, looking at the passwords, you can see that the password has been changed everywhere to @RealDonaldTrump. That is probably not what we want to do, though. We probably do not want everybody's password to be changed to this, but only one person's password to be changed to that. So if I add a where clause, like where username equals Trump, like that, there's only going to be one row that matches this condition right here. Only one row matches that. This row right here matches it. And so I'll run that. And now you can see we've changed Trump's password to this new value, and all the other passwords down here are staying the same. So for the purposes of the quiz, the thing to know is that the where clause right here, if there is no where clause, it will apply to everything. If there is a where clause, it only applies to the things that match this condition over here.
Output the entire table.
Question is, how did I output the entire table? This line 2 right here, select star from users. The thing to the right of from is always the table that you're working on. And then between select and from is the columns that you want outputted. You can manually specify which columns you want with a comma delimited list, like ID, comma username, like this. Or if you want everything, select star. And so this is very useful for debugging. But it's not, you're not going to have a select star on the quiz because that would just be too much stuff to try to write down. Good question. Any other questions about how the update command works? There's still a little bit more for us to talk about this problem, but the update command. Okay, then so the last part of this. Oops. Like this. Select count star from users where password is like this. And let's change. And before we do the count star, I'm going to just do select star from users. So down here, we're outputting everything from the users table, all the columns, all the rows, because I previously had just select star from users without this thing over here. I'm now adding a where clause over here, saying where password like this expression over here. And this parentheses, I think I skipped over this on accident before with the like statement, but the parentheses is like a wild card that means match anything at all. So at parentheses means at, and then the parentheses can match real Donald Trump. So if I run this, it will get me just that first row. Select star from users. And that's where password like at %. SQL does not care about the capitalization outside of parentheses. So it's good practice to make it capitalized, makes it easy to read, but not required. And so password like @%, the @ matches this @ right here. And then the % matches the real Donald Trump. So there's only one row that gets output down here because there's one row that matches the this expression. And so if we were to change that from a select star to a select count star like this, then the output would be 1.
So the % sign equates to like anything after the @ sign.
Yeah, so what password like @% right here, what that means is that the first character must be an @ and then anything else, % means I can match anything else. If we just had it like this, then the password would have to be exactly an @ % means the password starts with an @. Yes, Jackson.
For problem 14, where it says delete from messages for a message like, and then the %, because messages have a lot of information in them, it's like they have A's that are alone or an A that is part of a word. What if you took out some of those?
Yeah, let's do some more examples with this like and this % and see exactly how this % is going to work. And I think it'll be easiest to look at the usernames because that's a little bit shorter here. So let's change this to select star from users. Again, real quick, run that. And we want to find all of the usernames over here that contain the letter E. So select star from users where username like E% like this. And this E right here is lowercase, but anytime you're using the like command, it matches uppercase or lowercase. So this E% right here is going to match the word Evan over here, even though Evan is uppercase. And then the van over here will match this % sign right here. If I run that SQL, run that, we'll see that Evan down here is the only thing that matches. This says the very first letter of the string must start with E, and then there can be anything we want or nothing at all after that. If I wanted to match words that had E or strings that had E anywhere in the word, I can put a % beforehand, and this says match anything at all, and then there must be an E, and then there can be anything at all after the E. If I run that, then there's a handful more usernames that match that. Biden has an E in the middle right here. Evan right here, Mike right there, Kristen right there. And so this, the semantic meaning of this is that there just has to be an E somewhere in the string. If I were to take that to be just E, nothing will match because nothing is just the letter E inside of it. Did that answer your question, Jackson?
Would, when we're using the percentage signs, can you do equals instead of like?
Question is, does it make sense to do, does something like this work? And the answer is no, it won't work. The equals means that it has to be exactly equals. So this is actually looking for somebody whose username is E%. So the % thing is specific to the like operator, and the like operator does two things. Like operator is case insensitive and has the % wildcards.
When I put, I did select star for messages where message like A, and then I put no signs around it, and I expected it to get 1 because, or not 1, I expected to get that like I'm a baby, but then you have to put spaces between.
So yeah, the question here is, we have message like A, and there's a handful of messages over here where we have the word A contained all by itself inside of this message. And it's important that, so just just like Python, when we're doing equality, that it's equality of the entire string together. So this select star from messages, where messages like A, it means that the message must be just the letter A. Not that it contains the letter A anywhere in it, not that it contains a word that is the letter A, just that it actually contains, that it is only the letter A. Could be uppercase, could be lowercase, but it can be only the letter A. Here we have word letter A, and so this does not match. If I wanted to match messages that contain the word A, what I would need is % space A space %. Now this right here, this will match that string right there. Then to the left %, this is the left %, and then this is the right %. I run that SQL, and some reason it's telling me that there's an error here. I'm pretty sure there's not an error here. Start from messages, run SQL. Where messages like % space A space %.
Is it a message like?
Thank you. There was in fact an error. Yeah, last time I had an extra S over here, but it should be singular because the name of this column is singular, but the name of the table is plural. The name of this column is singular, but the name of the table is plural. And so now we're matching all of those messages that contain the word A. If I were to take away these spaces like this, then it'll match a lot more messages because it doesn't just have to contain the word A, but just contain the letter A anywhere inside of it, even if that's part of another word. Yes.
Could you quickly go over the descending and ascending from 6 and 7? Like, what is it ordering it by?
Question is on problems 6 and 7, when we use the order by, this column name right here, and descending into ascending, it orders things exactly as if it was in Python and use the sort function on this column right here. So it sorts things ASCII-betically on this column. Do that real quick right here, run that. And a good debugging practice is to actually put the column that you're ordering by right here. And so here are the usernames. I know it's ordering by the username because it says order by username right here. And it's doing it descending because I put the DES. And so ASCII-betically descending, Aaron at the bottom, Trump at the top. We're out of time for today. If anybody has more questions about this, happy to talk about that after class, or feel free to totally forget this until after Thanksgiving, and then we'll remember it on Monday and have our class then. But I hope you all have a good Thanksgiving.